Hey Omar, so we're gonna do the vector projection thing. This is my first time trying this like video camera thing, so hopefully it's okay. I don't know. Let's try it. Let's see what happens. So the first thing about so let's do two vectors. I'm just gonna draw. So I hope everything comes out okay. So this is this vector A and this is B. I want the projection of A on B. First of all that means is that I want to know what component, because you know how vectors have horizontal components and vertical components? So I want to know what component of this vector A is going to be on this vector. So the first thing you do is just create a right triangle. And they're asking you for this. That's what the projection of a vector is on another vector. Just that. What component is on it. You just create a right triangle to make it horizontal and vertical. And that's what you do. The first thing you need to do, well, you need to know the magnitude of this, and you need to make sure it's in the same direction as vector B. So making it the same direction as vector B is the easy part, because all you do is just do the unit vector of B. And what that that means it's the same direction as B, and the magnitude is 1. And you find that, and then you multiply it by the magnitude of the projection. So the unit vector of B the formula is B over the magnitude of B, which is like that. You can't see that. Let me move that up. Okay. So it's just that. So that's the unit vector. So I have to multiply that by the scalar magnitude of this. So the way to find this is you just do cosine, because let's say that's the angle, and this is vector A, right? So then the cosine of the angle, let me write it over here. Cosine angle is adjacent over hypotenuse. So it's like what you're looking for, the projection over the hypotenuse, which is A, and it's the magnitude. You gotta do that thing. So basically, it's that. So you want to multiply the unit vector by that. Because I wrote projection, it's actually not really the projection, because the projection has the angle with it, whereas this is not the angle, this is straight up magnitude. So you just want the magnitude times the unit vector. Anyway, the way to find that out is they extend this. There's a way to prove it, or one way to prove it, I guess. They extend this, and then they do the law of cosines to find the angle, because if you notice in the projection formula, they don't use cosine. So they, get rid of the cosine. So one of the important things to know, and I'll put it over here, is that the cosine of an angle equals, let's say, vector A times vector B. This is something you just have to know. And again, you prove it through law of cosines, which we can do, or you can just do yourself. Basically, this is A minus B. Or is it B minus A? It's one minus the other. Whatever. Anyway, so this is the cosine angle thing. And then you just do that times A, remember? Because that gives you the magnitude. So if I plug that in, so it would be the magnitude of A times B over the magnitude of A on the bottom times the magnitude of B. So again, I'm sorry you can't see it that clearly. So again, what I did is I used this, where from this we figured out that the magnitude of this is the cosine of the angle times that, because cosine equals adjacent over hypotenuse. And then the cosine equals this. So basically, you just substitute this into the cosine of this formula. You get this, the two a's cancel out. So you end up with the unit vector of B times this thing. Okay, so I went from lowercase to capital, but these are the same b's. So I'm going to go back to lowercase now. So it's B times A. I just changed the order, which you're allowed to do, over that. So that's what the projection is. That's how you find this value. You find the unit vector, and you find it's equal to cosine times the hypotenuse. And the cosine, using the law of cosines, which you don't have to do anymore, you just have to memorize it. You substitute it in, and you get what it is. And the thing to notice, so think of it this way. These are just two unit vectors, because it's B over magnitude of B, and here it's B over magnitude of V. So an easy way to remember is, if you're projecting something, if you're projecting A onto B, it's the unit vector of B times the unit vector of B times A, the other one. So I don't know, I hope that made sense. If it didn't, let me know. Okay.